So I have 12 minutes, right?
Yes.
12 minutes. All right. I don't run a timer on my phone, so I don't talk for too long. So my name is John Osborne. I'm the lead OpenShift architect for Red Hat Federal, and I'm also the co-author of a book that went in production on Friday called OpenShift in Action. Don't ever write a book unless you hate free time. Today I'm here to talk about Istio. Has anyone heard of Istio?
Google.
You have? Okay.
Google did it last time. Google last
Oh, okay, cool. Has anyone heard of Docker or Kubernetes? Okay, perfect. So Istio is a microservices service mesh. If you don't know what that is, don't worry, I'll cover it. But the entire idea of it is to make microservices easy. So microservices themselves are actually really hard. When they're done right, they create incredible benefits like scale, and you can work with independent teams, and they make resilient architectures, but essentially it's distributed computing. So it's a really hard problem to solve. And there's lots of things that you need to account for when you create microservices. For instance, you need things like service discovery to dynamically find services. You have a distributed system, so you need distributed tracing. So you need to find out if a service goes down that affects my app. Well, my app's made up of 10 different services. How do I know where that was, what that failure caused? Different things like that make microservices really hard. Now, Kubernetes actually provides a great place to run microservices. A lot of things come out of the box, things like service discovery, things like elasticity. You can scale, you can auto-scale based around metrics. If a container dies, it will spin one back up for you automagically. You can also use things like Prometheus to monitor all the metrics in your platform. OpenShift is a Kubernetes distribution with lots of other enterprise features on top of it, so you get all that stuff. You can also get logging, so the entire Elasticsearch logging stack to gather all your logs from your containers, CI/CD pipeline, things like that come out of the box. But neither Kubernetes nor OpenShift is a complete microservices platform. So there's tons of remaining microservices requirements. You need end-to-end application delivery. You need the ability to to elastically scale for certain and connect things through client load balancing. You need policy enforcement points, other things like that make microservices actually really hard. So what that actually means for implementing these things are things like circuit breaking. So an example of this would be, I have a database. My app starts up, it tries the database 3 times, the database isn't there. Well, then what happens? Does the whole app crash? Is it a cascading failure that goes through all 7 other services that require that? You need to have failback. You need to have other things in the microservices architecture. So traditionally, the way this has been done is through Netflix open source. Has anyone used Netflix OSS? Okay, so I won't go into too much of what this is, but these are basically a group of projects that Netflix open sourced. They've been real leaders in the microservices community. And I won't even bother going into each one specifically. But the way it's been done traditionally with Netflix OSS actually provides plenty of drawbacks. So all those libraries that I mentioned, or in the last slide, are embedded locally in your application. So those are jars if you're running Spring Boot, if you're running Vertex. That's a language, a framework. You need an implementation for Netflix OSS for that specific version. So it gets really unwieldy, right? Because you need all those capabilities that I mentioned, load balancing, bulkheading, circuit breaking, those types of things. And you need one for each version of software that you're rolling out. So if you're rolling out Spring Boot, if you're going to roll out Python, if you're going to roll out Ruby, you need an implementation of something to do that in every single framework. So it really becomes unwieldy and not very maintainable, right? So what if there was a better way? So a cleaner way to do this would be to use a service proxy. And Kubernetes has a concept of a sidecar. Has anyone heard of the sidecar pattern in Kubernetes? Awesome, Chuck has. So basically what the sidecar is a pod in Kubernetes is a collection of one or more containers, typically just one. But it can be one or more. So with a sidecar pattern, you actually run a proxy that runs a container proxy inside the pod with your app. And implement all that stuff there, and you don't have to couple your app to all the Netflix OSS pieces. And it allows you to be much more polyglot. So if you want to run things like Go, things like maybe certain Python libraries that don't actually have microservices solutions yet, It's a very easy way to do it. So now we're at Istio. So the proxy that I mentioned is actually called Envoy. It came out of Lyft. Lyft open sourced it about a year ago. And Istio is a way to manage a fleet of envoys. That's why it's called Istio. And it's a service mesh. So it's basically a control plane to manage all these envoy points and provide a lot of the microservices functionality that you need for your app to run and provide a complete microservices platform. And I'm going to skip over this slide. So a couple cool things about it. It has this thing called the pilot. The pilot is essentially the glue. So it does run outside of Kubernetes, but Kubernetes is the main deployment mechanism for it. So you need Envoy to actually implement all the proxying, but eventually that needs to get plugged into Kubernetes somehow. So Kubernetes services, Kubernetes routing, things like that. So the pilot is really the glue between Envoy and Kubernetes, and it also controls all the traffic in your cluster. And I'm going to show you a couple of really cool demos. It's incredibly powerful what you can do. You can do things like mirroring traffic between applications for testing. You can do things like A/B testing, which I'm going to show you as well. You can inject failures, make a really resilient architecture. And there's also something called Mixer. So Mixer is the policy enforcement point. So that's things like quota management, whitelisting certain services that can access other services, maybe other security pieces that you built in. Now there's authorization built into OpenShift, and now in upstream Kubernetes is authorization built in there too. But that's really about deploying pods. It's not really about the actual authentication of your app, like if you're using SAML or something like that. So that's where Mixer can come in and provide those things for you. So really, once you add Istio on top, you get really a complete platform. You can do things like tracing. You can do things like resilience, where you can do circuit breaking, provide failback for services that break. I think I'm getting to demo time here, so try to get through these tasks. Okay, cool. So I'm going to give you a quick demo. This is an application, which I'm going to show you. It's got a product page. Behind it, there's several microservices. And there's a review page providing, and it's going to round robin between these, or pick them randomly. Probably better off I just show you at this point. So I have this page here. And if I just refresh it, you'll see on the book reviews right there, the stars went away. If I refresh it again, I now have the black star reviews. If I refresh it again, now the red star reviews. So that's actually hitting, every time I hit this app, it's actually hitting a microservice behind it. Now what I'm going to show you is really cool because Istio is incredibly powerful and it can control all the traffic in your cluster. So what I'm going to do is I'm going to first create a rule that applies to only certain users to access the version 2 of that application, which is the black stars. So I'm going to put the microphone down for 1 second. So what I did there is just create a route rule, and I'll show you what that is. I'm using Visual Code. All this is running on OpenShift on Azure Gov, by the way. So I created a rule, and the rule is right here. And I created a rule that basically said, if the user is JSON, and this is really powerful because if the user is JSON, only go to version 2 of the application, which is the black star review. And it's going to pull that information out of the header. So it's incredibly powerful, especially if I do something like A/B testing. I don't know if you're familiar with A/B testing, but it's basically a way to do human factor testing, like usability, business value. This is like what Facebook does when they roll out features. They'll roll them out to a small set of users, find out if the users like them. If those users like them, they roll them out to more users. So if my username is Jason and that's in the header, then I'll hit version 2 of the application 100% of the time. But if not, I'll still round robin. So here I am. I should be still round robining at this point. Yep, and I am. If I sign in as Jason, I should only, now I'm hitting refresh again, and I'm only getting the black star reviews here. So It's incredibly powerful. Now, so for this user is only getting this version 2 of the application, but everyone else is getting version 1 or version 3 of the application. Now, say I want to do some testing on here and I want to inject some failures. Well, one thing I can do in a microservices architecture, it's really important that you have SLAs for all the services in your environment. And those SLAs might be on the order of milliseconds or even seconds, but typically milliseconds. So I'll inject a rule that will, I'll show you what it looks like here, but essentially it's an extension on the previous rule, except that it's going to add a delay of 7 seconds to the backend microservice. So I'm injecting a failure, and this is really for testing purposes because I want to see what this looks like. Now, so I create another rule, and it'll create a 7-second delay. And if I go back, I can take a look at that. If I refresh the page, you see it's hanging there. It hasn't reloaded yet. Typically, a 7-second response will fail an application from a microservices. This is where I need to realize I need to do something like handle different fallbacks differently. So maybe there's a better error message here, or maybe something else happens, or maybe it falls back to a different microservice or an old version of the microservice that's on the back end there. And if I open up my developers tools here, I should be able to see, this is just what comes with Chrome out of the box. Let's see here. Might have to refresh that. Yeah, and you can see that there was someone that pushed 7 seconds. Some of these requests pushed 7 seconds up there. Sorry, that refreshed pretty quickly. But that was basically what caused my microservice to fail. So if I come in here, I'm plotting these things out with Prometheus. Has anyone heard of Prometheus? It's really the de facto monitoring metrics tool for Kubernetes. I can come in, take my Istio request count. This is going to give me the count of every single request, so I can come here, take a look at this, and if I want to graph this out, I can use the dashboard that comes out of the box with Istio, which is based around Grafana. I've had some success rates. Let me refresh that. And I can start tracking out my requests through here as well, so I can graph all that out. Now let's say one thing that's, I think, incredibly powerful about Istio in general is that it can also mirror traffic. I think it's probably the coolest thing about it, because a lot of customers, as they move to containers, are looking to do things like blue-green deployments. Blue-green deployments have gotten incredibly popular. So originally they were called red-black deployments, came out of Netflix. That's their color is red-black. And they had been doing this for years, where they basically spun up, if they had a new deployment to go into their application, they would spin up a second virtual machine. Netflix is highly coupled to AWS. So if they spun up a new application, they'd spin up new VMs in AWS, and they'd have all their VMs running version 1, all their VMs version 2, and they'd test in production with version 2 before they cut over. Now, that was really cool, but not many people were doing that, because not many people want to pay for double the amount of storage or double the amount of VMs in AWS, right? So, but as people moved to containers, this became a lot more viable option, because containers are a lot more lightweight. They take up a lot less resources. But you're still not really testing in production. You're testing a version 2 in a production environment, but you're not testing with live traffic, right? So it's not really quite the same thing. You're kind of testing it in the environment and then deciding when to cut over. So Istio can actually mirror traffic in an environment, and let me show you what that looks like. So this is a demo 2 here, and on mirror environment, so I have an application that's going to send all the traffic to version 1, but it's also going to mirror the traffic to version 2. Now this can actually be a little bit dangerous if you think about it, because version 2 might have PII information. Maybe you need to drop that information, not save it to a database. I might want version 2 not to just drop the data or process it or not send it somewhere else. So there's a couple of things here that are important. So for safety. So the responses from version 2 are ignored by the proxy. And it also passes a special host parameter called -shadow. So if I need to do anything else, like if it is processing like PII information or some other classified information on a classified environment, I can drop all that as well. So I'll show you what that looks like. Should be done in a second. I'm probably over in time, aren't I? Yes, I am. Okay. Can I have 1 minute? Okay. So go back to my second demo. So I have this application called HTTP bin. It's incredibly simple. It's literally just showing my headers and other things that I'm coming through the browser. And I have a second version of it as well, which I will show you. I'll create basically a clone of the same service. Let me switch that. So when I start refreshing this page here, I should see all the logs are still going to version 2 of or version 1 of my application. And if I come look at the logs for the container, I'll see all my requests here coming through. Let me refresh it here. There we go. So these are all my requests coming through here, but I want to mirror that. So I want to create another route rule, and this is really cool. This is using Microsoft Visual Code, which is an awesome IDE, by the way, if you are so inclined. So I can create another rule, and it's basically going to say, what this rule says is send all my traffic to version 1, but then mirror it to version 2. So all the live traffic is going to version 1. Version 2 will get a copy of it, but the responses will be dropped and the header will be added with a -shadow. So if I need to do something custom for privacy or security, I can do that as well. There we go. I feel like I'm really out of time now, but that definitely took more than minutes. Okay. So there we go. Still no logs, but I'm going to go hit HTTP1 again. I got 10 seconds left. So I'm refreshing. It's going to HTTP1, as you can see, version 1. But if I check the logs for version 2, I should see. It didn't work. Well, I'm out of time, so what can we do now? But version 2 would get all the copies of the logs, and then I can process that, test it. It's basically a way to reduce risk with a blue-green deployment before I roll it into prod. So appreciate everyone for your time, and apologies for going over. So. Oh yeah, sorry. So, yeah, I won't need any more time, but go to this URL if you want to play with this yourself. bit.ly.learn. It spins you up an environment on Red Hat's hosting with Istio already installed, and you can run through a lot of similar demos on there yourself. So it's bit.ly/learn Istio. That's bit.ly/learn Istio. So definitely go there, try it out for yourself, and play with it if you want to. It's all hosted by Red Hat. There's nothing involved with it. It's all free. Just go. It's got Istio, and everything's hosted in the cloud, and you can go spin it up and play with it. So, yeah, sorry about that. Thanks.